This is the EdExcel GCSE 9-1 Maths Paper 3 from the November 2020 series, and it's a higher paper. Question number 1. We have to simplify n cubed multiplied by n to the power of 5. First of all, when we have the same base and we are multiplying, we add the powers. So if we have a to the power of m multiplied by a to the power of n, we add the powers here, giving us a to the power of m plus n. And so if we were to simplify n cubed multiplied by n to the power of 5, we end up with n to the power of 3 plus 5, giving us n to the power of 8. So we have n to the power of 8. And now for part B, we have to simplify c cubed multiplied by d to the power of 4 divided by c squared multiplied by d. Well, when we have the same base and we are dividing, we subtract the powers. So if we have a to the power of m divided by a to the power of n, this gives us a to the power of m subtract n. Now, first of all, here we've got c cubed d to the 4 divided by c squared d. D is the same as d to the power of 1. And so if we focus on the c's first, we have c to the power of 3 subtract 2, that's c cubed divided by c squared, multiplied by d to the power of 4 subtract 1. And so we end up with c to the power of 1 d cubed, which is the same as c d cubed. So we have c d cubed. Now for part C of the question, we have to solve 5x over 2 being greater than 7. Well, if we multiply both sides by 2, then on the left, those 2's cancel out. So we are left with 5x being greater than 7 multiplied by 2, which is 14. And if we now divide through by 5 on both sides, then we end up with x being greater than 14 over 5. So we have x being greater than 14 over 5. Question number 2. Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers per hour. He then runs a distance of 12 kilometers at an average speed of 8 kilometers per hour. We have to work out the total time Andy takes. Give your answer in hours and minutes. Well, the total time, t, that's equal to, well, the time it takes him to cycle, we've got the distance, 30 kilometers, divided by 24 kilometers per hour, which is the speed. And then we add on to this the time it takes for him to run. We've got 12 kilometers divided by 8 kilometers per hour. And so if we work all of this out, 30 divided by 24 plus 12 divided by 8, it turns out we get 2.75 hours. Now the 0.75 hours. If I multiply this by 60, I get 45 minutes. And so what we will end up with is 2 hours and 45 minutes. Question number 3. A number m is rounded to 1 decimal place, and we have to complete the error interval for m. Well, the upper and lower bounds we can find by working out 9.4 plus minus 0.5 of, well, if it's given to 1 decimal place, we multiply 0.5 by 1, and if we work this out, we either get 9.35 or 9.45. So we either have 9.35 or 9.45. Question number 4. Maisie knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 meters by 9 meters. Grass seed is sold in 2 kilogram boxes. Maisie wants to make a rectangular lawn 10 meters by 14 meters. She has 5 boxes of grass seed. For part A, has Maisie got enough grass seed to make a lawn 10 meters by 14 meters? You must show all of your working. Well, first of all, what's the area of this rectangular lawn? The area of this rectangular lawn will be 5 meters multiplied by 9 meters, which is 45 meters squared. Now, we know then, for 45 meters squared, we require 3 kilograms of grass seed. Now, what's happening over here is she wants to make a rectangular lawn 10 meters by 14 meters. What's the area of this lawn? Well, that will be 10 meters multiplied by 14 meters, which is 140 meters squared. And so with this, we can find out how much grass seed we need. So for 140 meters squared, we can find out how much grass seed we need. How do we go from 45 meters squared to 140 meters squared? Well, if I divide those, it turns out we need to multiply both sides by 3.11, etc. And so we will multiply the 3 by the 3.11, etc. And if I multiply this by 3, we get 9.33, etc. So we've got 9.33, etc. kilograms. Now, she has 5 boxes of grass seed. Now ultimately what we want to do is find out how much, to find out if he's got enough grass seed. Now, she's got 5 boxes of grass seed, and in total, the grass seed is sold in 2 kilogram boxes. And so therefore, how much kilograms of grass seed do we have? We've got 2 kilograms per box, and we've got 5 boxes. So we've got 10 kilograms. We've got 10 kilograms of grass seed which we need. And so therefore we see that the 10 kilograms is greater than the 9.33, etc. kilograms. And so what we can conclude from here then, she's got enough. And now for part B of the question, Maisie opens the 5 boxes of grass seed. She finds that 4 of the boxes contain 2 kilograms of grass seed, and the other box contains 1 kilogram of grass seed. Does this affect whether Maisie has enough grass seed to make a loan? Give a reason for your answer. Well, what is the total over here? We've got 4 times by 2 plus the 1, so we get 9 kilograms of grass seed. And so therefore, because the 9.33 etc. which we calculated before is greater than the 9 kilograms which we have available, we can say there is not enough. Question number 5. Amanda has 2 fair 3-sided spinners. We've got spinner A and spinner B. Amanda spins each spinner once, and we have to complete the tree diagram. Well, if we take a look at spinner A, then the probability that we land on a 2, that's going to be 1/3. And so the probability that we don't land on a 2 will be 2/3. And if we take a look at spinner B, well, that will be identical to this. The probability that we land on a 2 will be 1/3, and the probability that we don't land on a 2 will be 2/3. And this will be repeated over here. The spinners are independent. And now for part B, we have to work out the probability that spinner A lands on a 2 and spinner B does not land on a 2. So spinner A lands on a 2, so let's just highlight this. So we've got spinner A landing on a 2. And then spinner B not landing on a 2. That will be over here. So we need to multiply the 1/3 by the 2/3. And so if we do that, 1/3 multiplied by 2/3 will be 2/9. And so the required probability then will be 2/9. Question number 6. We've got 2 graphs over here. 5x minus 9y equals negative 46 and y equals negative 2x. And we have to use these graphs to solve the simultaneous equations. 5x minus 9y equals negative 46 and y equals negative 2x. They both intersect at this point here. The coordinates of this point, we've got negative 2, 4. And so we've got x equals negative 2, y equals 4. Now for part B, we've got y equals x squared minus 4x plus 2. And what we have to do for part B is use the graph to find the estimates for the solutions of the quadratic x squared minus 4x plus 2 equals 0. Well, where the graph equals 0 is where it intersects the x-axis. That's at over here and over here. And so the coordinates of this point, we've got x equals 0.6. And we also have this point over here, which is x equals 3.4. Question number 7. There is a total of 45 boys and girls in a choir. The mean age of the 18 boys is 16.2 years. The mean age of the 27 girls is 16.7 years. We have to calculate the mean age of all 45 boys and girls. The total ages of the boys we've got 18 multiplied by 16.2, and if I work this out, 18 multiplied by 16.2, we get 291.6. The total ages of the girls, we've got 27 times 16.7, and if I work this out, we get 450.9. And so what we can do with this is find out the total ages of all the boys and girls. So the total ages of the boys and girls, we've got 291.6 plus 450.9, and it turns out we get 742.5. And so if we were to find out the mean is equal to 742.5 divided by 45, and if I work out what this is, so if I add on 291.6 and then divide this by 45, it turns out we get 16.5. So we have 16.5 years. Question number 8. There are some counters in a bag. The counters are blue or green or red or yellow. The table shows the probabilities that a counter taken at random from the bag will be blue or will be green. And the probability that it's blue is 0.32 and the probability that it's green is 0.20. The probability that a counter taken at random from the bag will be red is 5 times the probability that the counter will be yellow. There are 300 counters in the bag. We have to work out the number of yellow counters in the bag. Well, if the probability that red is 5 times yellow, if I call the yellow X, that means red will be 5x. And we know that probability adds up to 1, so we've got 0.32 plus the 0.20 plus 5x plus another x equals 1. So we've got 6x plus 0.52 rather equals 1. 6x is equal to 0.48, and therefore x is equal to 0.08. And so we've got 0.08 over here, and 5 times this is, work this out, 0.08 times by 5, we get 0.4. And so what we need to do is find out the number of yellow counters in the bag, and therefore we need to work out 300 multiplied by 0.08, and it turns out we'd get 24. So there's 24 yellow counters in the bag. Question number 9. The diagram shows a prism. The cross-section of the prism has exactly one line of symmetry, and we have to work out the volume of the prism, giving our answer to 3 significant figures. And before we do anything else, what we need to do is find out the perpendicular height of the triangle. the height over here. And for us to do this, well, if we think of us having a right-angled triangle, then we can see that this length here is half of the 10, which is 5 centimeters, and so the height will equal 5 multiplied by the tangent of 40. And so the area of the cross section, so the cross section is equal to the area of the triangle, which is 1/2, times by the base, which is 10, multiplied by the height, which is 5 times by the tangent of 40. So this is the cross-sectional area. And if we work out what this is, we've got 5 times by 5 tan of 40, which is, well, we also need to add on the area of the rectangle, 12 times by 10. And so if I add on 120 to this, we get 140.97, etc. centimeters squared. And if I multiply this by 20 to find out the volume then is equal to 140.97, etc. multiplied by the 20. So we get 2,819.54, etc. And so to 3 significant figures, the volume is 2820. Question number 10. A person's heart beats approximately 10 to the power of 5 times each day. A person lives for approximately 81 years, and for part A we have to work out an estimate for the number of times a person's heart beats in their lifetime. Give your answer in standard form, correct to 2 significant figures. Well, if we've got 10 to the power of 5 each day, in a year we've got approximately 365 days. And for 81 years, if I multiply this quantity by 81, we can find out the number of times a person's heart beats in their lifetime. So let's work this out. I've got 10 to the power of 5 times 365 times 81, and I get this value here, 2956, and then the 500,000 at the end. Now I need to put this into standard form. So if the decimal point is over here, I need to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 times to the left. So I get 2.9565 times 10 to the power of 9, and to 2 significant figures I end up with 3.0 times 10 to the power of 9. So I've got 3.0 times 10 to the power of 9. And now for part B, 2 times 10 to the 12 red blood cells have a total mass of 900 grams. We have to work out the average mass of 1 red blood cell. Give your answer in standard form. Well, what I need to do over here is work out 90 divided by 2 times by 10 to the power of 12. So if I work out the 90 divided by 2, I get 45. So what this is the same as is 45 times by 10 to the power of negative 12. And this is the same as 4.5 times 10 to the negative 11. Question number 11. The diagram shows a triangle P on a grid, and triangle P is rotated about the origin to give triangle Q. Triangle Q is translated by 5, negative 2 to give triangle R. For part A, we have to describe fully the single transformation that maps triangle P onto triangle R. Well, first of all, let's transform triangle P to give triangle Q. Let's rotate it by 180 degrees, and if I do that, this point would be mapped to negative 1, negative 2, and then we've got negative 1, negative 5, and then I've got negative 2, negative 5. So let's join all these up with a straight line. Here you can see we've got triangle Q. And now if I translate this by the vector 5, negative 2, so I need to go 5 across. So here's 1, 2, 3, 4, 5, and then negative 2, there's 1, there's 2. So if I translate this shape over here, we end up with this over here. We've got now triangle R. And what we need to do is find out how we go from P to R. Well, if I join up this point and this point, and then join this point over here, we get that over there, and now join the corner one up. So joining this one up, you can see here is the point of center of rotation, and so we've got a rotation by 180 degrees about the point 2.5, negative 1. And now under the transformation that maps triangle P onto triangle R, the point A is invariant, and we have to write down the coordinates of point A. What does invariant mean first of all? Invariant means the point does not change. And so the point which doesn't change during the transformation, we've got 2.5, negative 1. That point doesn't change. So from P to R, that point doesn't change. So we've got 2.5, negative 1. Question number 12. For part A, we have to express x over x plus 2 plus 2x over x minus 4 as a single fraction in its simplest form. Well, here we'd have to combine the fractions. I've got x multiplied by x minus 4 plus 2x multiplied by x plus 2 divided by x plus 2 multiplied by x minus 4. And so I need to simplify all this. So I've got x times by x, which is x squared. Then I've got x times negative 4, negative 4x. Then I've got 2x times by x, that's 2x squared. 2x times by 2, that's 4x. And then on the bottom we still have the x plus 2 multiplied by the x minus 4. And so then on the top we have x squared plus 2x squared, which is 3x squared, and on the bottom we've got x plus 2 multiplied by x minus 4. And so this is the result that we end up with. And now for part B of the question, we have to expand and simplify x minus 3 multiplied by 2x plus 3 multiplied by 4x plus 5. Now here, I recommend working out two brackets multiplied by each other and then multiplied by the third. And we can do this. First of all, if I multiply the 2x plus 3 by the 4x plus 5, then I've got x minus 3 multiplied by, well, 2x times by 4x, that's 8x squared. And then I've got 2x times by 5 plus 3 times by 4x. So I've got 10x plus 12x, which is 10x plus 12x is 22x. 3 times by 5 is 15. And so what I need to do at this point is expand all of this out. So I've got x times by 8x squared, so that's 8x cubed. X times by 22x, that's 22x squared. X times by 15, that's 15x. Negative 3 times by 8x squared, that's negative 24x squared. Negative 3 times by 22x, that's negative 66x. Negative 3 times by 15, that's negative 45. And so if I tidy all of this up, we end up with 8x cubed, subtract 2x squared, subtract 51x, subtract 45. Question number 13 for part A. On the grid, show by shading the region that satisfies all of these inequalities. We've got x is being greater or equal to 0. Well, first of all, I need to draw the line x equals 0. And I want everything bigger than that. So to do that, I draw the line x equals 0. I'll show that over here. So I've got the line x equals 0, and I want everything to the right of that, as we see here. Then I've got x being less than or equal to 2, so I draw the line x equals 2. So I've got x equals 2, and I want everything to the left of that. So that's shown over here. And then I've got y being less than or equal to x plus 3. Well, first of all, draw the line x plus 3 equals y. So x plus 3 equals y. I've got a gradient of when it crosses through the line y equals 3, as we see here. So I've got y equals x plus 3, and I want everything below that line. So if I draw everything below that line, like so, then that inequality is shown. And then I've got 2x plus 3y, being greater or equal to 6. So for me to do that, so when x is 0, y is 2, and when y is 0, x is 3, and so if I draw that line, it goes through this point and this point, and so drawing that, I've got the line here, 2x plus 3y equals 6. Now if I rewrite this inequality over here, so I've got y equals, I've got 3y being greater or equal to negative 2x plus 6, and then at that point, if I divide through by 3, I've got y is greater or equal to negative 2/3 x plus 2. So I want y to be greater or equal to this line, so I want everything above that line. As if I do show that, everything above that line. So the region I want will be the region shown here. So this is the region I want, and we will label this region R. And now for part B, the diagram below shows the region S that satisfies the inequalities y is less than or equal to 4x, y is greater or equal to a half x, and x plus y is less than or equal to 6. Gregory says that the point with coordinates 2, 4, so 2, 4 is on the line over here. He's saying that this point does not satisfy the inequalities because it does not lie in the shaded region. Is he correct to give a reason for your answer? Well, because it lies on that line and we've got a less than or equals to, we can see here then, the point 2, 4 does satisfy x plus y being less than or equal to 6. Question number 14. The points B, D, E and F lie on a circle as we see here. ABC is the tangent to the circle at the point B. We have to find the size of the angle ABD. So we want to find out what this angle here is. We'll call it theta. And we have to give reasons for each stage of our working. Well, first of all, we can find the angle DBF, and we can do that by recognizing that opposite angles in a cyclic quadrilateral add up to 180. So we've got 180, take away 100, which is 80. So I've got 80 degrees for this angle over here. And after this, we can find, well, let's just write down the reason for this. Cyclic angle, opposite angles in a cyclic quadrilateral add up to 180. And then we've got the angle BFD. We can find out what this angle is over here, recognizing that we've got angles in a triangle adding up to 180. So the angle BFD is equal to 180, subtract 80, subtract this 40. And if I work out what this is, we get 60 degrees. So the angle here is 60 degrees. And the reason is angles in a triangle add up to 180. and then the angle ABD then, that will equal 60 degrees because of the alternate segment theorem. So the angle ABD is equal to 60, and that's because of the alternate segment theorem. Question number 15, we have to prove algebraically that 0.73 recurring can be written as 11/15. Well, first of all, if I let x equal 0.733333, etc., because we've got one digit repeating, if I multiply this by 10, then 10x is equal to 7.33333, etc. And therefore, if we subtract, 9x is equal to, well, the terms here cancel out. So we've got 9x, which is equal to 7.4. And so therefore x is equal to 7.4 divided by 9. So if I work this out, 7.4 divided by 9, well, let's just double check this, 7.3, take away that 6.4. So if I do 6.4, we get 6.6 rather. So 6.6 divided by 9, we get 66/90, which is the same as 11/15. Question number 16. Here is a speed time graph for a car. And for part A, we have to work out an estimate for the distance the car travelled in the first 30 seconds. So to do this, in the first 30 seconds, we can estimate the area under the curve by approximating it as a triangle. And so the area of that triangle then, we've got 1/2 times by the base, which is 30, times by the height, which is 9. So here we end up with 15 times 9, which is 135. So we have 135 meters. And then for part B, is your answer to part A an underestimate or an overestimate to the actual distance travelled by the car in the first 30 seconds? Give a reason for your answer. Well, it's an underestimate because the triangle is below the curve. And then for part C, Julian used the graph to answer this question. We have to work out an estimate for the acceleration of the car at time 60 seconds. Here is Julian's working. Acceleration is speed divided by time, so we've got 13 divided by 60, which is 0.216 recurring meters per second squared. Julian's method does not give a good estimate for the acceleration at time 60 seconds. Explain why. Well, what he's supposed to do is draw a tangent at 60 seconds, and he's not done that. So he has not worked out the gradient of the tangent at time 60 seconds. Question number 17. The histogram gives information about the distances 80 competitors jumped in a long jump competition, and that's what we see here. And what we have to do is calculate an estimate for the mean distance. Well, what we need to do is find out the required frequencies of each. So, for this bar over here, 7.2 subtract 6.4, that's 0.8, so the class width is 0.8, and if I multiply that by 10, I get 8 over here for my frequency. And then here we've got 0.4 multiplied by the height over here. So we've got 50 multiplied by 0.4. So that's 20. And then here we've got 0.4 times by 100. So that's 40. And then here we've got 0.2 multiplied by 60, which is rather 0.2 multiplied by 60, which is 12. So at this point, we can find out knowing the frequencies, we can find out the mean. And to do this, we need to use the midpoints of the class width. So, for the mean, if I was to work out what this is, I've got 8 multiplied by 6.8. I've got 20 multiplied by 7.4. Then I've got 40 multiplied by 7.2, rather 7.8. And then I've got 8.1 multiplied by 12. And then I'm going to divide that by 8 plus 20 plus 40 plus 12. So if I work out what this is, 8 times by 6.8 plus 20 times 7.4 plus 40 times 7.8 plus 8.1 times 12 divided by 8 plus 20 plus 40 plus 12. So it turns out I get 7.645. So that's the mean. 7.645. Question number 18. The diagram shows a cube and AH is equal to 11.3 centimeters correct to the nearest millimeter, and we have to calculate the lower bound for the length of an edge of a cube. You must show all your working. So AH over here is equal to 11.3 centimeters to the nearest millimeter. And what we can do with this is find out well, if I was to find out the lower bound of AH is equal to 11.25. And so what we can do here is use 3D Pythagoras to find out the length of the edge of a cube. So therefore, if I say that the length is x, that means I've got x squared plus another x squared plus another x squared, which is equal to 11.25 squared. So we have 11.25 squared. So 3x squared is 11.25 squared. So if I've got 11.25 squared, and if I divide that by 3, I get 42.1875 for x squared. And so therefore x is equal to the square root of this, which is this quantity here. X is equal to 6.495190528. And then I've got centimeters. Question number 19. A, B, C, D, E, F, the smaller hexagon, is a regular hexagon with side lengths of x. So here I've got x, 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 and x. And I enlarge this hexagon by the centre F by a scale factor of p to give this larger hexagon f, g, h, I, j, k. And if I enlarge it by scale factor p, that means this length is px, 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 px. And if this entire length is px, that means this length will be px subtract x, which is the same as p minus 1 x. And it's the same thing here. We would have p minus 1 x. And what we have to do is show that the area of the shaded region is 3 root 3 over 2 multiplied by p squared minus 1 x squared. Now, the way we'll approach this is to look at the smaller regular hexagon, and what we'll do with this is find out the areas of one of those triangles and then multiply it by 6. Now we've got a regular equilateral triangle here, so the area of A, B, C, D, E, F, that will equal, well, I've got 6 regular equilateral triangles, and the area of each one is given by 1/2 x squared sine 60. So if I work out what this is, sine 60 is root 3 over 2, and I'm multiplying this by 3, so I end up with 3 root 3 over 2 x squared as the area of the hexagon. Now, if my length scale factor is p, that means my area scale factor will be p squared. And with that, I can find out the area of f, g, h, I, j, k. I multiply this area, the 3 root 3 over 2 x squared, by p squared, because I'm stretching it by a scale factor of p, so the area increases by a factor of p squared. And so therefore, the shaded area is given by, well, I've got the larger area, 3 root 3 over 2 x squared p squared, subtract 3 root 3 over 2 x squared. And if I factorize out a 3 root 3 over 2, then inside the brackets we've got p squared minus 1 x squared. And that's exactly what I wanted to show. Question number 20. Here is a list of 5 numbers. We've got 98 to the 53, 98 to the 64, 98 to the 73, 98 to the 88, and 98 to the 91. We have to find the lowest common multiple of these 5 numbers. Well, you can go from here to here by multiplying by 98 11 times. Here to here you can multiply by 98 9 times. From here to here you can multiply by 98 15 times, and here to here you can multiply by 98 11 times. So essentially, when we come to find out the lowest common multiple of all these, that's just going to be 98 to the 91, because we can always get to here by multiplying by 98 a certain number of times. Question number 21, we've got 5c plus d equals c plus 4d, and we have to find the ratio c to d. Well, what we need to do here is get all the c's on one side and all the d's on the other side. So if I start off with 5c plus d equals c plus 4d, then I can rearrange this to say that 4c is equal to 3d. And if that's the case, then if I divide through by d and then divide through by 4, that means c over d is equal to 3 over 4. And so therefore the ratio c to d is equal to 3 to 4. Now for part B, we are given that 6x squared plus is equal to 7xy plus 20y squared, where x is greater than 0 and y is greater than 0. And what we have to do here is find the ratio x to y. So to do this, what we can do is recognize we've got a quadratic. 6x squared equals 7xy plus 20y squared. Let's take everything over to one side. We've got a quadratic, so we've got 6x squared minus 7xy minus 20y squared equals 0. Now at this point, we could factorize this. Now the way we'll factorize this is, let's pretend the y wasn't there and just continue as normal. So we are looking for two numbers which multiply to give 6 times negative 20, which is 6 times negative 20, 6 times negative 20 gives minus 120, and which add to give negative 7. So what could those two numbers be? Well, here we could have a 15 and an 8 involved, and because we want these to add to give negative 7, here we've got negative 15 plus 8 gives negative 7. And they multiply to give negative 120. So when I come to factorize this, I've got 6x squared, and then I could have the negative 15xy plus 8xy subtract 20y squared equals 0. Now if I split this down the middle, then I end up with 6x multiplied by, well, I'd have a 3x multiplied by 2x minus 5y. And then here I've got, if I take out a 4y, then I'd have 2x minus 5y. And the 2x minus 5y is common to both, so by grouping, we end up with 3x plus 4y multiplied by 2x minus 5y equals 0. And if that's the case, then from here we've got 3x equals negative 4y, And from this we will have to reject, and that's because both x and y are greater than 0, and from here we've got 2x equals 5y, so x over y is equal to 2 over 5, and from that the ratio x to y is equal to 2 to 5. So we've got the ratio x to y equaling 2 to 5.